So let's look at a problem now for Avogadro's law, and we'll also go over STP, okay, in this case, standard temperature and pressure. So first of all, what is the new volume of a gas when 2.4 moles of gas are added to 3.6 moles of a gas which occupy 2.50 liters, okay, of volume. So which means that your initial moles, okay, which is N1, is equal to 3.6 moles. Your initial volume, not liters, volume 1 is 2.50 liters. Your new moles are 3.6 moles plus 2.4 moles that were added in there. And then the question is, what's the new volume, okay, for this one? So that's your problem setup. And so the total moles that are in the final volume will be 6.0 moles. So Avogadro's law is V1 over N1 is equal to V2 over N2. We are solving for V2, so V2 is equal to V1 times N2 divided by N1. And so volume 1 is 2.50 liters. The number of moles finally are 6.0 moles. Initial number of moles were 3.6 moles. Now in this case, since it's Avogadro's law, if you increase the number of moles, you also increase the volume. So that is what our answer should be after we finish the calculation. And the answer for this problem is 4.17 liters or 4.2 liters if you come to the right significant figures. And that is correct because once you added more moles to the mixture, then now you have a higher volume. Okay, so that's the simple case of Avogadro's law in one case. Now, a little bit about STP. STP is standard temperature and pressure. Okay, and so this is going to be of 1 mole of gas. All right, so standard temperature is 0 degrees Celsius, which is also 273 Kelvin, and pressure is 1 atmosphere. Okay, so remember we talk usually about 4 values, P, V, N, and T. That's what we've learned about so far. So what we are saying is that the pressure at STP is 1 atmosphere, the N is 1 mole, the temperature at that point is 273 Kelvin. And so then the question becomes about volume. Okay, what is the volume? So under these conditions where you have 1 mole of a gas under 1 atmospheric pressure and at 273, then the volume occupied by a gas is 22.4 liters, okay, of gas. And these are standard numbers. There is nothing much to think about this because this is just standard. Okay, and so if you're trying to do a calculation, you can very easily use these numbers. All right, so for example, for Avogadro's law, it's easy to calculate the volume of gases using this standard, okay, that we have here. So for example, if I were to write an equation, okay, of hydrogen plus oxygen to give water, and this is all gas phase, and once we balance the equation, we should have 2 of water here and then 2 of hydrogen over here. Okay, and so now let's say this is at STP. Okay, so under STP we can say that if we have 2 moles of hydrogen, we have 1 mole of oxygen, and we have 2 moles of water. And this is not even at STP, this is, you know, stoichiometry, plain and simple. But if I say now that I have 34 liters of hydrogen gas, then how much oxygen gas do I have? And because the relationship here is 2:1, then it means that the amount of oxygen gas that I have is 34 divided by 2, because the ratio is half of that of hydrogen. So which means that I have 17 liters of oxygen. The volume of water would be equal to volume of hydrogen because they are equal in molar quantity, so which means this is also 34 liters. Okay, so that is how it goes as far as the volume of gases is concerned. All you have to do is look at the total number of moles of gases that you have. Okay, so similarly, if we had hydrogen plus nitrogen to give ammonia, okay, then in this case, when you balance the equation out, we have 2 and then 3 over here, balance the equation, so which means that we have 3 moles of hydrogen, 1 mole of nitrogen, and then 2 moles of ammonia. Okay, and let's say we have this at STP. So if volume of hydrogen is 9.0 liters, what is the volume of nitrogen at the same time? The relationship is 3:1. So which means that the volume of nitrogen should be then 3 liters. Okay, that's how it goes. Volume of ammonia will be a little bit different because now you have to do the molar ratio. Okay, because the relationship between hydrogen and ammonia is 3:2, or you could look at nitrogen and say if nitrogen to ammonia, okay, is 1:2. So if nitrogen is 3 liters, then ammonia must be 6 liters. Okay, that's how it goes. So that's the nice thing about dealing with gases. You don't have to do any major calculations. You can just look at the molar ratios, provided everything is as at STP. Okay.